our experiment number 4 is effect of intensity of light on stopping potential. Now this is the link for the virtual lab. Now here, see, this is the source of light, this is the photocell. Okay, now first of all we switch on the light. You can see light is falling here on the photocell. Now here, this is a voltmeter, we can take reading from voltmeter, and here is a microammeter. This is microammeter, so we can measure and record current from here. Now what we have to do first, here see certain materials are given, so we have to choose a material: copper, sodium, zinc, platinum and unknown material. So let us say copper. If in exam you are asked to select a material sodium, then you have to select like this. Okay, so let us experiment from copper. Now area, another parameter is area, which we are not going to change. Now intensity of light, so we are studying effect of intensity of light on photocell. So I show you, suppose this is 5, intensity of light is 5 here. If I change 10, you can see the light, 15, 20, you can see light becoming bright, 25 and 30. So from here we can vary. Let us take the reading on 5. Now here the voltage is 0 volt. Now see, what is the principle of photocell? That it works on the principle of photoelectric effect. That means when light falls on certain material, then it emits electrons. That material emits electrons. So this effect is called as photoelectric effect, and this cell is based on the principle of photoelectric effect. Now the light falls on this photocell, then what happens? Current flows through it. Now what happens when negative potential is given? That means in this photocell there are two electrodes, one is anode and another one is cathode. So anode is given as a positive and cathode is given as negative. When this light falls on the cathode, because there is a coating of photosensitive material on the cathode, so when this light falls on this cathode, it emits electrons, and as anode is at positive potential, it attracts the electrons, and in this way current flows through it. Now here in this experiment we are giving reverse potential or the negative potential, like anode is kept negative with respect to cathode. That means due to this light, when this cathode ejects electrons, this anode repels the electron and the photoelectric current decreases. Now as we increase the reverse potential, and as we go on increasing, the current goes on decreasing, and at one particular potential photoelectric current exactly becomes 0. So here we will get 0 reading. So the negative potential at which photoelectric current becomes 0 is called as stopping potential. So here we have to study the variation of intensity of light on the stopping potential. So what we do, we have selected as a 5, intensity as a 5. Now we will vary the voltage. So here 0, we can record this value. On 0 voltage the current, you can see 3.86. You have to write in your table. Now वी विल टेक इट वेरी, ये जो बटन है यहाँ से हम इसको वोल्टेज को वेरी करेंगे लाइक दिस. सो आई विल टेक -1 as it is a negative potential, so it is -1. So what is the current? We have to record this value. Current is 3.36. Then we will do -2. The current we can record at -2 voltage, current is 2.86, -3, current is through 2.36. We will record all these values. Now -4, you can see it is 1.86. So we can see as the negative potential increases, photoelectric current reduces. Now at -5, 1.36, -6, 0.86. Now here onwards very slowly we move because we have to observe that the potential exactly where this current becomes 0. So I take here -7. So current is 0.36. Now very slowly I go back. I am observing the current where it becomes exactly 0. Can we see? At voltage -7.8, here also we can say -7.8, current is exactly 0. We again scroll down. We just take it backward. See, at 7.5, 7.7, it is 0.01, and exactly at -7.8, the photoelectric current becomes 0. So what is the value of stopping potential here? It is this value. This value is the stopping potential, the negative potential given to photocell where photoelectric current becomes exactly 0. So in our first column we will record these values. Now we will change this intensity from 5 to 10. Again we start our readings for the column number 2. So the voltage is 0 at 0 volt, current is 7.72. So we'll again go at -1, we will record this value 6.72, -2 5.72, -3 4.72, -4 3.72, -5 2.72, -6 1.72. Now here very slowly we move forward. We are observing this. So -7 0.72. We go very slowly. We see exactly where the current becomes 0 is the value -7.8. If we increase the voltage, reverse voltage beyond this, the current will be 0. But we have to find the voltage exactly where current becomes 0. So this is the value. So do you remember for 5 what was the stopping potential? It was exactly -7.8. Now if we increase it 15, again I show you from here. See, you just observe here, -7.8, the same value. If I again increase this from 15 to 20, again we can see, I just scroll here. You can record from here, 0, 0, then -1, -2, -3, and so on. I'm showing you here. We observe this and we move slowly. You can say -7.8. So what does it mean? As we go on increasing the intensity of incident light, the stopping potential of this material remains constant. So there is no change in the stopping potential. But if I change the material, suppose sodium. So for sodium, see, at -7.8 there is a current. So this is not the stopping potential. I again it goes beyond the range. We choose zinc. See, for zinc, for zinc, stopping potential is -8.20. We have seen for sodium, stopping potential is the another one. So for a given material, stopping potential is constant. But as the material changes, stopping potential for different material is different. But as intensity of incident light varies, it doesn't affect on the stopping potential, because stopping potential is the characteristics of a material. So in this way you have to record this value for different intensities of incident light. You have to record the negative potential and the values of current from these two, and then you have to plot the graph of stopping potential versus photoelectric current, and we can show that what is the variation. So in exam you have to draw graph also, and you have to show the stopping potential. Hope you understand this.